Good morning. Welcome to the lecture on continuous probability distribution. Probability function. If f of x is greater than 0 and integral from minus infinity to plus infinity into f of x dx is equal to 1, then the function f of x is called probability function. Cumulative distribution function. If x is a continuous random variable with probability density function f of x, then the function f of x is equal to p of x less than or equal to x is given by integral from minus infinity to plus infinity f of x into dx. If r is any real number, then p of x greater or equals to r can be integral from r to infinity f of x dx. When p of x less than r, it can be 1 minus p of x greater or equal to r, which is 1 minus integral r to infinity f of x dx. Mean, variance and standard deviation. Mean is given by integral minus infinity to plus infinity x f of x dx. Variance is given by integral minus infinity plus infinity x minus mu the whole square into f of x dx, or integral minus infinity to plus infinity x square f of x dx minus mu square, where standard deviation is given by root of variance. Example: show that the following functions are probability density functions. F of x is 2x when x is ranging from 0 to 1 in the open interval, 0 otherwise. Given f of x is 2x at 0 less than x less than 1, which implies it will be 0 when greater or equals to 0. Let integral from minus infinity to plus infinity f of x dx will be integral 0 to 1 2x dx, which on integration gives x square by 2, where 2 and 2 cancels, we get x square, that is 0 to 1. On substituting the limit, we get 1 as the answer. Hence, it is proved that f of x is a probability density function. Let's take an illustration 2. In this, a random variable x has the density function f of x is equal to k by 1 plus x square minus x minus infinity less than x less than infinity. Determine k and hence evaluate p of x greater or equals to 0, p of 0 less than x less than 1. Solution: f of x is greater or equals to 0 if k greater or equals to 0 and integral minus infinity to plus infinity f of x dx is 1. This implies by taking the given function k divided by 1 plus x square into dx is equal to 1. This by using the properties of integral, when we have same limits with the negative and positive, which can be written as twice of integral 0 to infinity k by 1 plus x square dx is equal to 1. The integral of 1 by 1 plus x square is tan inverse x. So we get 2k tan inverse x, where upper limit is infinity, lower limit is 0. We know that tan inverse of x when x tends to infinity will be pi by 2. So pi by 2 divided by 2, pi by 2 into 2, it will be 1 minus tan inverse of 0. We get it as k, that is 2k times of pi by 2 minus 1 is equal to 1, which implies k is 1 by pi. First case, p of x greater or equals to 0. This is 0 to infinity 1 upon pi 1 divided by 1 plus x square into dx, that is 1 by pi tan inverse of x, which on integration we get pi by 2 after integration and limits is substituted. Pi and pi gets cancelled, we get the answer as half. Similarly, for the second one, p of x varying from 0 to 1, 1 by pi into 1 by 1 plus x square dx, which gives 1 by pi into tan inverse x. Limits are from 0 to 1. We know that tan inverse of 1 is pi by 4 and tan inverse of 0 is 0. Therefore, 1 by pi into pi by 4 minus 0, that gives 1 by 4. Thank you.